Hi my friends, today we model the part number 11, a SPIGOT, from my collection of 100 parts. The interesting part of this object, SPIGOT, is that we see here two holes, conical holes, which have a definition about the taper 1 to 50, and you can read what it is. The taper K is the rapport of the diameter difference of two cross sections of a cone and the axial distance between the sections. This is special, and this is why this part is to be modeled by us. We start with the template and we select the XY plane, draw a rectangle with this side as a center line. Now we look to the dimensions here, 31.5 and 28. 31.5, okay, and 28. Finish sketch, revolve, okay. Here is a chamfer, the default chamfer of 2 millimeters, okay. And now we start a new sketch, F7, to see inside. We project the generators because we need them, and we place two lines which must be center lines, and we place a slope or sloped line to each one. In order to create this conical hole with a taper 1 to 50. We discussed about this at the beginning, and we have to respect this indication. I made for you a sketch. If this diameter is 2 and this is 5, A and B, then the diameters C and D depends on both A and L, which is the length of the holes. How they depends from these two dimensions? C is A plus L multiplied by 1 to 50 the taper. This is K in both cases. This means that we have to place an expression A plus L divided by 50. You should note that if I choose here a radius instead of diameter, the same expression is placed. When I say taper applies on diameters, where A and B are diameters, we refer to a conical hole and not a slope line. First, I want you to remember that D1 is 28. Yes? This is the length of the holes, conical holes. We place here a dimension, which is the radius on the left. The diameter is 2 divided by 2. Even if you think they are exaggerated, you have to get used to these procedures. When you meet a radius and the drawing has the diameter, like here, you place an expression and you feel good. This is 2 and this is 5. The taper is 1 to 50. The expression is not a big deal. This is A plus D1, this is 28, the length of the hole, divided by 50. That's all. The other one, the same. B plus D1, 28, divided by 50. Let's connect these lines to have a profile, because we apply revolve to obtain these conical holes. Finish sketch, revolve. This is the first profile. This is its axis. Cut plus. We have two profiles on the same sketch. Axis, cut, OK. Now we can look to these holes, which are conical as we have in the drawing. And now the holes. There are two. Cylindrical, not through, with diameter. This is concentric with the part. Let's start with it. 15 with the depth of 18. 15, 18. A sketch, start and finish. And then hole, 15, 18. I choose this distance. I want to place a distance, not through, like this. And dimensions are here. The point is this one, and the hole is made. On the other side, we have to place a point on the same horizontal with y horizontal, because x is to the right, and at a distance of 5. But to the other direction, yes, 5, Finish sketch. Let me see. Yes, to the right. And now the other hole, which is diameter 6 and depth of 12. Diameter is 6 and the depth is 12. Okay, now we can look inside by using a sketch. Yes, to apply F7. You see that two holes which are partially connected for some fluid to go up and down, I suppose. Finish sketch, delete sketch. What is the other way to look inside? I told you, is to use view, half section view, choose the plane and move the arrow to see inside. Yes? From nothing to nothing. Good. The last thing to do is to select material, is steel carbon and steel polished. That is the part, and its data are here. High properties, physical, update, look to them. Close. That's all for today. Bye bye.